Hi guys, today I'm going to take a look at different cloud paradigms for doing things in the cloud. So this is more about trying to think about the cloud not as a single set of technology that you just put applications on, but different ways to think about how one would use the cloud. So the terms I want to discuss are cloud ready, cloud native, cloud first, and born in the cloud. I want to talk about how these relate to applications and then talk about the implications that they have on the applications that adopt one of these four different paradigms. So the four terms that I mentioned are cloud ready, cloud native, cloud first, and born in the cloud. Now, don't think of these as four distinct categories. Rather, these are a gradient, and these are something that you could lay atop a gradient of applications to try to provide some taxonomy for where an application might fall on that gradient, because there's certainly a lot of overlap between each one of these. So what I'm going to do here is define each one of these and then talk about its implications in terms of architecture, technology, and focus. So cloud ready is the most basic of these. And this is basically where you take a traditional application and you package it in a way that can leverage cloud functionality. So this is just basically taking old applications and making them run in the cloud. Now, at the most fundamental definition, that's what this is doing. And so architecturally, this thing is not going to look a whole lot different than what it did when it was running on Prem. So this is not going to have microservices. It's not going to have modular architecture. So these are typically going to be more monolithic applications. So this might use something like in-tier architecture, or it might even be something that ran on a mainframe back 30, 40 years ago. But it's going to adopt a pattern that was designed for data centers. So with an in-tier application, you had maybe a client. It might have been something like a desktop client or a web-based client, and then it connected to some kind of server that had all of the code that it needed to run. That's your business tier. And then underneath that, it had some kind of data storage. That typically would be some kind of database server. And so that in-tier technology would have been very stratified and not very scalable beyond just adding more CPU and RAM to the servers that ran them. It was very monolithic in its approach. And for the time, that was fantastic. That worked great. But as applications move to the cloud, that approach doesn't scale well beyond an application that was designed to run for a single business. Rather, with the cloud, we're thinking about scaling applications to millions of users in a global context, maybe. So in any case, this one is taking advantage of some of those more traditional patterns, but enabling it to run in the cloud. Now, some of the ways that might be done is just by using virtual machines in a cloud environment. It could be containers, and it could take advantage of even some of the storage offerings and networking capabilities that the cloud offers. So with these different ways of packaging applications, instead of just installing it, you might deploy it as a VM image. So some organizations have taken some of their older applications and created virtual machine images and put them into marketplaces. And then those marketplaces just deploy that image as a virtual machine into cloud infrastructure. Or you could do something very similar with a container, where you take an application, make a container image, and then deploy that into some kind of container infrastructure. Now, just because it's a container doesn't mean that it's cloud native, cloud first, or born in the cloud. It's just packaging it in a way that basically keeps the application the same, but enables it to run in a container. And so that approach, or the virtual machine approach, allows it to take advantages of things like storage, such as file shares offered by something like Azure Files, and networking capabilities that are things like the virtual networks that are available in most cloud networks. But most of that responsibility for storage and networking with traditional applications is handled by the operating system. The actual application just kind of assumes that they're available without building any kind of redundancy or self-healing capabilities or any of that. Rather, it just depends on the operating system to kind of take care of that. With cloud native, on the other hand, that responsibility becomes much more a part of the application and less a part of the operating system. And so that's one of the different assumptions that cloud native and cloud first and born in the cloud make. And we'll get to that in just a minute, but it's kind of assuming that the storage is there. So that storage could be a disk that's a part of the VM. It could be a file share on a server. It could be a SAN. It doesn't care. It's just assuming that, oh, that drive is available, I can write to it. And it might have some error handling if it's unavailable, but very minimal, if any at all. And the focus of this, as mentioned, is mostly about ensuring that existing applications can be hosted in the cloud platform without requiring a complete redesign of the application. And so this is about operational efficiency from the perspective of somebody that's coming from an on-prem environment. Like, how can I optimize my applications for on-prem or the cloud without having to completely redesign anything? So I just want to make sure that I'm running in the cloud, making sure I'm using the cloud in a way that will enable this application to run, but I don't want to change the application. And so I can then use a cloud ready approach to give me that much and then take advantage of some of the cloud, but not the full scope of what the cloud has to offer. So cloud native is the next one. And this one is really where we start to talk about getting something that is optimized to take advantage of the cloud. So cloud native is about building and running applications that take advantage of the cloud model. This is about how the applications are built and run and deployed, not where they are built, run, and deployed. So location is not important here. So we typically think of cloud as being, Microsoft Azure, AWS, or GCP, but cloud really is about how applications are run and less about where they are run. So you can still do cloud native on-prem. If you adopt the cloud native paradigms, you can build a cloud on-prem and still be cloud native. And so this is more about the how and less about the where. So this gets into architectures and practices and principles that really think about applications that are more oriented for what the cloud has to offer. So this is going to be thinking about how I can build applications that are scalable, automatically scalable for that matter. How can I build in resiliency to my applications? How can I build in modularity to my applications to enable them to scale independent of other parts of the application? How can I automate all of the infrastructure underneath the application, such as setting up load balancers, setting up the actual underlying compute that they run on, setting up the storage that they need? All of that is automated, and it's defined using code rather than manually configuring it like we traditionally did on premise. It's about building applications that can take advantage of all of that automation, and so that they can move from one node to another and not have to freak out because all of a sudden the configuration changed or something like that. It's about thinking about applications in that paradigm. So it puts a lot more responsibility of being aware of what's going on the actual application, and less about assuming that, like we typically did with cloud traditional applications that might be more cloud ready, but not necessarily cloud native. So architecturally, to accomplish a lot of that automation and scalability, we typically focus in on microservices and microservice architecture. Now, it doesn't mean that microservices is actually what you're doing, but the microservice architecture, as in this most pure sense, is where everything is broken into small independent services and they all communicate over well-defined APIs. Now, in an ideal sense, that's true. In reality, sometimes that's not always possible, especially if you're coming from an application that is more what we might call traditional and more monolithic, and you're trying to move it towards cloud native. So in this approach, what you end up doing is you take that monolith and you start carving off pieces into smaller services. And so you still have that monolithic core, but you have this surrounding suite of services that are more like microservices, but you still have that core application that is eventually going to be carved up to the point where it is itself a microservices, and you realize a fully blown microservice application. And so cloud ready to cloud native sometimes is a journey. It's not a big bang change. And so you can kind of move in that direction, even though you might start with cloud ready, but move towards cloud native by adopting a more microservice architecture. And it doesn't even have to be microservice. It can be modular even. It's just basically about getting closer to that microservice and less towards that monolith. And so there's a lot of middle ground there between the monolith and the fully realized microservice architecture. Now, for the kind of technologies that you would use in a cloud native approach are generally going to be technologies that support microservices, or a lot of this stuff that we've seen and talked about. So using things like containers and container orchestration. So Kubernetes comes to mind for this, for deploying those services that are independent of each other and then scaling them independent of each other, is what a container orchestration platform is going to enable. It might take advantage of things like service mesh, and this is going to be useful for things like discovering service endpoints for that configuration change. If I moved a container from one environment to another or one node to another, it can figure out where things are. Service meshes also provide security and other things that were typically done by more traditional in-tier approaches with things like load balancers and firewalls and what have you. Service meshes will provide a lot of that security and routing and discoverability for microservices and what have you. And then it talks about immutable infrastructure. So this is talking about the ability to configure things through code in a way that once it's deployed, you don't really touch it. You kind of let the infrastructure be what it is, but you still have the ability to orchestrate that infrastructure using whatever orchestration technology you're using. You use APIs for interaction rather than integrating a bunch of classes together at the code level. Your contracts are not defined by method signatures as much as they are by APIs, and everything interacts through APIs. And all of this makes applications portable, scalable, and resilient across that infrastructure rather than a single code base that gets deployed all or nothing. Rather, everything is deployed independently and scaled independently, and it can be brought up independently and be shifted independently without having to bring down the entire application to do all of that. So that's the advantages of cloud native, but of course, the responsibility gets shifted back more towards the application developer to make the application designed in a way that it can be fault tolerant, it's stateless so that it can scale well, and it can take advantage of all of these different kinds of things that we do for cloud native implementations. But the main thing that you're going to hear in cloud native conversation is an emphasis on containers in particular, because like we said, cloud native is not so much about the where, it's about the how. And so one of the technology choices that enable this is container technology, because container technology is cloud agnostic. It runs on Prem, it runs in the cloud, and it enables all of these things regardless of the cloud that you choose. So the focus of this is on application development techniques and cloud environments aiming to enhance scalability, flexibility, and resilience at the core, rather than just the minimal effort that I need to get something in the cloud. Rather, this is trying to take full advantage of what you can do in the cloud. So the third one here is cloud first, and sometimes it's confused with cloud native, but it's different. So cloud first is more of a strategic approach, and this is more driven by an organization's business needs and the business needs that drive a lot of the decision makings, rather than what happens over here in cloud native. What cloud native, again, is more about trying to optimize for what all the cloud has to offer, and cloud ready is more about getting things in the cloud. But cloud first is more about trying to understand how one can take advantage of cloud service providers over on-premise solutions. So the on-premise solutions versus the cloud service providers is really what this is getting at. So this is more about the decision-making process and less about any kind of solution or any kind of operational efficiencies that might be gained from adopting a cloud native approach. It's more about how can I take a given application and run it in the cloud and minimize or optimize or take advantage of something in the cloud that is better than what I could do on premise. So this is less tech oriented and less architecturally oriented and more business oriented in its process. Given that, though, a cloud first approach is typically going to lean into cloud native more because of what cloud native offers for realizing some of the benefits of the cloud. So when we think about the three major areas in the cloud with infrastructure as a service, platform as a service, and software as a service, cloud first is going to look for solutions that are going to be more heavy in the platform as a service and software as a service than they are going to be into the infrastructure as a service. Because again, it's about making a business decision that's going to take advantage of the cloud. And so some of the drivers behind this would be flexibility, agility, and cost efficiency at the organizational level. So this is less driven by technology and more driven by business processes and business thinking. And like I said, within that framework, what can I do in the cloud that is going to drive that forward? Well, if you drive that forward in the cloud, you're typically going to want to operate cloud native solutions that are cloud first in their implementation. So this would be, how can I run microservices on platform as a service, for instance? How can I create applications that are modular in their design, that to scale independent of one another in a way that is cloud first, that minimizes my need for infrastructure to run that. So it's going to create scalability that's going to be much more in line with my utilization than reserving a virtual machine that I reserve at its maximal capacity. And whether I use that or not doesn't matter. I'm still paying for that virtual machine. So cloud first is looking about optimizing. So it's probably going to be cloud native, but it's going to be doing that in the cloud rather than trying to think of it in a more abstract context. So cloud first will adopt some technologies that are going to be very specific to a given cloud service provider. So that might adopt something like Azure Container Apps over Kubernetes, because Azure Container Apps gets me out of the business of having to maintain Kubernetes clusters. It's a much simpler approach, and it's more platform as a service oriented, but it enables me to do microservices in a similar way that I would do those if I was running those on-prem in Kubernetes. So in that way, I'm taking advantage of a serverless compute option that runs containers without the headaches of having to maintain a complex infrastructure that gives me cloud native on-prem. So that one is a cloud native offering that is both cloud native and cloud first. So the last of these is born in the cloud. Now, born in the cloud means that an application was never running in a traditional infrastructure. So the application probably never ran in some kind of on-premise data center or any kind of legacy infrastructure. So it's going to adopt paradigms that are inherently cloud native. So it's from the ground up, the application is adopting cloud native as its paradigm for not only running the application, but also deploying the application and operationalizing the application as well. So this one is not going to have to deal with a lot of the baggage that comes along with migrating an application from a monolith to something that is more cloud native. It doesn't have to go on that journey. It's from the day one cloud native in its approach. And so it's going to take advantage of everything the cloud has to offer, and it's going to be scalable, flexible, cost efficient out of the gate. It may use microservices, it may not. It might use something else that you might have in terms of architecture. One popular option might be serverless computing. So taking advantage of something like Azure Functions or AWS Lambdas. It might use containers, but it typically is not going to prefer something like containers that require it to use a heavy infrastructure deployment like Kubernetes. It's probably going to prefer something like Azure Container Apps that's more platform as a services, even if it uses containers to host an application. But many of these will end up using serverless anyway, because serverless is something that is a programming paradigm that, if you adopt the programming paradigm, allows you to deploy the application in a way that's going to scale quickly and scale up and scale down. And your cost is going to be very much in line with the actual utilization of the underlying compute that you're using. And so this is going to have infinite scalability, and it's going to take advantage of a lot of managed services, like even managed database services that are going to be more serverless in their orientation. So this might be something like Azure Cosmos DB, where in that case, you have a service that has scalable storage and scalable compute that is serverless. And this is not going to rely on more traditional databases such as SQL Server, although that one is evolving quickly to becoming something that is very cloud native rather than more traditional in its orientation. So all of this enables somebody to innovate quickly and scale efficiently and keep costs down for that matter. And so the focus here, again, is on leveraging technologies, not just for operational efficiency, but it's fundamentally a driver in the business model and the product development. And it's also about trying to come up with a competitive advantage. So all of this born in the cloud is more about just going all in on the cloud and abandoning anything from the past. Now, In some cases, some application developers will see their older technology and say, rather than try to adapt this to the cloud by either just making it cloud ready or going on a migration process from cloud ready to cloud native, they will just abandon that, sunset it, and completely rewrite an application from the ground up using something that is born in the cloud. And in that case, they are taking full advantage of cloud native from day one in this complete rewrite. Now, that's not always possible. Sometimes it is. It just depends on the applications. But in any case, what you typically end up with in this kind of vision of the cloud is you sometimes end up with a little bit of all of this. You end up with cloud ready, cloud native, and born in the cloud, all working together in a harmonious environment. If you have the advantage of going to completely born in the cloud, then that's great. But in reality, you end up with typically a myriad of different things. Some of them are just cloud ready. Some of them are on a journey to becoming cloud native, and some of them are completely born in the cloud and taking full advantage of that. And cloud first being just a paradigm to adopt, it depends on where the cloud might be, on-prem or in a cloud service provider. But all of this is typically orienting yourself towards a specific application and trying to think about where it lies on this gradient. So over the next few videos, I'm going to be revisiting this concept, probably with a smattering of other things that I'll be talking about, but I want to revisit this using an example application. So the example application will be an on-prem application, and then I'm going to take it and make it cloud ready, then I'm going to make it cloud native, and then I'm going to take it to be born in the cloud. And all along the way, I'm going to show you what it takes to make something cloud ready, what it takes to make something cloud native, and what it takes to make something born in the cloud. So we're going to have 3 iterations on this application that will look different in their implementation, but they'll be functionally equivalent to one another. But their paradigms will be radically different and how they're implemented and how they're deployed and so on. So look forward to those videos. And as always, thanks for watching. Like and subscribe. If you have any questions about this, drop them in the comment section down below. And I'll be glad to talk about this in other contexts as well. And look forward to those future videos and other videos that come out on my channel.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.